Hello. Hello. Okay. Yes, hello everyone. Welcome on YourPedia platform. I hope you all are fine, preparing well. So, guys, today we are going to solve very good questions from the subject mechanical vibration for the upcoming examination related to BHEL and HPCL. So I picked some very good question, guys, from this subject, mechanical vibration. I hope you revised some basic formula related to this subject. Otherwise, with concepts, I'm going to discuss all these questions, guys. Okay. So let's start our discussion. Yes, Ajay, good evening. Thank you. So, guys, let's start our discussion. First, we're going to start with very basic question. Actually, I arranged these questions in such a manner so that we will be able to revise the entire subject. Directly, I'm not going to pick the questions related to the transmissibility or the what you can say, if I kind of magnification factor or other some kind of torque method to solve some kind of complex vibration problem. So I'm not going to move directly to those kind of things. Gradually we will move to the difficult question, but yes, first we are going to start with very basic things: vibrations, then the different methods, springs in series, springs in parallel, these kind of cases. So I hope you will keep that patience and you will try each and every question with me, guys. In these examinations, they are not going to ask you gate level question, guys. Okay, that I hope you all understand. That's why practice is required. You need to boost your speed, you need to increase your speed, and as well as accurately you need to answer. So accuracy, speed, both matters for these kind of examination like BHEL and HPCL, because in a very limited time, 150 minutes for HPCL, you need to solve more than 240 questions. Okay, chaliye shuru karte hain. Time is very important for us. So this is the first question in front of you. This is first question, guys, in front of you. Please read and try to answer. Which of the following are the basic building block of a mechanical system? Which of the following are the basic building block of a mechanical system where forces and straight line displacements are involved without any rotation? Guys, any vibrational system like machine, a building, anything that you can represent by a combination of what? You can represent any mechanical system by a combination of spring, mass, and a damper system. Whether it is a machine or any particular building, you can represent by a combination of spring, which will have some stiffness, a mass, and a damper, which will having some damping coefficient. What is a damper, guys? Damper is a body which is going to offer the resistance to the vibration. Spring is a body that represents the elastic nature of body, guys. Actually, in machine there may be some spring there, but in actual case there may not be any spring like in building. But what this K is representing? K is representing the elastic nature of the body, and M is representing the mass. Because vibration are nothing but the to and fro motion of a body. Okay, and that motion we will get when the continuous change in the kinetic and potential energy is going to take place. So mass is capable of storing the kinetic energy. This is going to store the kinetic energy, and spring is going to store the potential energy, and this damper is going to offer the resistance to the motion. There are different type of damping. Here we will discuss later on. Okay, but damper is what? Damper is a resistance to the vibration. That's why in any of the vibration system, there must be spring, there must be some mass, there must be some dashpot, or what you can say, resistance to vibration. Dashpot means resistance to vibration. Okay, so these are the three things which must be there in any mechanical vibrational system. Okay, so what will be the answer, guys, for this question? This D is the right answer. D क्या हो जाएगा बच्चों? This is the right answer. Will there be any special preparation session for computer IT? Prithviraj, that soon we will start. We are going to start. Okay, we are hiring faculties, mentors for computers also, and soon, hopefully within next 10-15 days, we are going to start computer related modules also. This time there is no such module going on, but yes, there is a hope. And yes, we are going to start some computer related domains also. So this is next question, guys. Second question in front of you. The number of degree of freedom of a simple pendulum. How many are the degree of freedom of a simple pendulum? What is degree of freedom, guys? Degree of freedom means the number of independent coordinates required to define the motion of any system. Like here, if you will show a kind of spring, single spring, a mass, okay, here only the displacement of the mass will be what, x. So this is having a single degree of freedom system. Its natural frequency omega n will be under root k by m, where k is the stiffness of the spring and m is the mass. Similarly, if you're having a kind of pendulum system, what do you mean by pendulum? In pendulum, you will have some string. This is a string, and this is the mass attached, which is known as bob mass. Okay, this is the mass attached, and if you will just move it here, it will store some kinetic, it will store some potential energy. So potential energy will convert into kinetic, and you will have somewhat, you will have a oscillation or to and fro motion. So that is also a kind of vibration. Here the natural frequency will be what, under root g by l, where l is the length of the string, guys. In case of pendulum, simple pendulum, the natural frequency will be g by l, guys. Just remember, very very important, pendulum frequency is independent of the mass, guys. If you are having a pendulum, that is independent, frequency is independent of mass. That depends on what the length. So frequency is under root g by l, where g is the acceleration due to gravity and l is the length of string. Many times you are going to face some question like, if you are decreasing the length half, or you are increasing the length 2 times, what will be the change in the natural frequency? Okay, so mass से कोई फर्क नहीं पड़ेगा whether you are touching m mass, 2m mass, 3m mass, 4m mass, as long as length is same, the natural frequency is not going to change for the pendulum. Okay, all these system, guys, a pendulum, spring mass, simple spring mass system, these are known as single degree of freedom system, guys. The degree of freedom of a simple pendulum is 1, because here you will have only theta. Okay, so degree of freedom is simple pendulum, simple spring mass system is 1. But if you're having these kind of arrangement, 2 springs, this is first spring, and suppose this is another spring, and they're connected to some mass. Okay, here what you can say, something like this. Let me take it here, something like this. Okay, okay, something like this. So here the degree of freedom will be what? Suppose it is having displacement x1, it is having displacement x2. So here degree of freedom will be 2. One more thing, guys, let me tell you, if you are having any kind of distributed system, like suppose you are having a beam, okay, whether it is a simply supported beam. So if you are having a beam or shaft, it will have infinite degree of freedom. So if you are having any distributed system where you can assume that some infinite number of masses are distributed over the entire length, then degree of freedom becomes infinite. So just remember, the degree of freedom of simple pendulum, single spring mass system is 1. These kind of system, 2 masses, 2 spring, the degree of freedom is 2. And if you are having 3 spring, 3 mass system, the degree of freedom is 3. But if you are having a beam, okay, whether there is a point load acting on that or a kind of distributed load is acting, the degree of freedom will be what? Infinite. Chaliye, let us move to next question. For this question, the B is the right answer. Let us move to next question, guys. Question number 3. A harmonic motion is given, represented by this. Guys, you know what is a harmonic motion? Harmonic motion is a special kind of periodic motion, a motion which repeats itself after an equal interval of time. That is known as a periodic motion. Motion of an object may be periodic, may be non-periodic. We are not going to discuss about non-periodic motion, guys, here at graduate level. Periodic motions are of different types, okay, but harmonic motion is a special kind of periodic motion in which the acceleration is always directed towards the mean position. That's why harmonic motions are represented by sine function. Okay, generally we represent harmonic motion x equal to a sine omega t plus minus phi. Okay, plus minus something like this. So harmonic motion we represent it like that, where x is the displacement, this is the maximum amplitude. Okay, this is the angular velocity, okay, and this is the phase difference, guys. This is phase difference that you need to remember. This is a kind of representation of a harmonic motion. X equal to a sine omega t, where x is the displacement, this is a is the maximum amplitude, this 30 is what, this is the omega, angular velocity or natural frequency, and this is what, this is the phase difference. Okay, now if you observe it here, guys, in this equation, what is asking you is asking the time period. Guys, there are some basic things related to the vibration, like the natural frequency omega. Next, there is a frequency in hertz. If you want to find out frequency in hertz, then also you can easily find out, because there is a relationship between W and F. You need to remember omega equal to 2 pi F, where this F represents frequency in hertz, number of cycle completing per second. Okay, where this is the in frequency in radian per second. There is a difference. This is the frequency in radian per second, and this is the frequency in hertz, which represents number of cycles per second. So from this, if you are able to remember this, F is nothing but 1 by 2 pi into W. Okay, and guys, the frequency is reciprocal of time period. Okay, so this you can write it as 1 by T. So 1 by T equal to 1 by 2 pi into W, or directly you can remember the time period is nothing but 2 pi by W. Time period of any particular vibrational motion is 2 pi by W, where 2 pi is a constant, W is what? This is your angular velocity or frequency in radian per second. So now if you'll observe it here, guys, the W is very clearly visible to you. W is very clearly visible to you. W is what? 30. Now here only you need to put this. So this is 2 pi by 30. This is the time period. So this is 2 into 3.14 divided by 2, 30, or this is 3.14 divided by 15. So further, if you will divide, this is not going to go on 15. So 0 point, this will go on 2, then 2. Again, it is not going to go 1, 4. Kya jayega? It will go on 9. So it will be close to this 0.209 second. So time answer will be what, guys? The answer will be option B, 2.209 second. Okay, guys, please check. 4.409 is wrong, guys. This is wrong. I don't know what mistake you are making in this question. Charan Raki, 0.409 is not right. B is the right answer. 0.209 second. Please check it again. A motion, a special kind of periodic motion in which acceleration is always directed towards the mean position, that is known as what? That is known as the harmonic motion. And in harmonic motion, we represent as a function of sine or cos, x equal to a sine omega t plus phi, where phi is the phase difference. So if you will compare it here, this and this, you will get W omega equal to 30, and W time period is equal to 2 pi by W, angular velocity. So if you will put it here, value 2 pi by 30, you will get the answer 0.209 second. B will be the right answer, guys. Yes, good. Guys, I already mentioned earlier, there are different kind of ways by which we can offer resistance to the vibration. Actually, friction is good for vibration, guys. Friction is not good for all other cases, but it is very good for vibration, because if there is a friction between the various parts, that is going to offer some resistance to the vibration. Okay, so there are many ways by which we can provide damping in a system. Damping means, damping का मतलब क्या होता है बच्चों? Damping means resistance to vibration. Resistance to vibration. Okay, we can provide resistance to vibration by some kind of viscous means. You can allow the system to move in some kind of fluid. So when it is going to move in the fluid, then again some kind of resistance the fluid is going to offer, and due to that some kind of resistance will be there and vibration will be minimized. So that is known as viscous damping. Guys, if there is a direct surface to surface contact between the two bodies, due to that also the friction between the two bodies, some resistance will be there to the motion, against the motion. That is known as what? A kind of friction or column damping. So in column or dry surface damping, there will be direct contact, the direct surface to surface contact between the two bodies, and due to that the resistance will be there. Okay, and guys, there is a very important thing which you need to remember about column damping. In column damping, the frictional force, what you can say, the resisting force is going to remain same. Okay, तो वो magnitude क्या रहता है उसका same रहता है. Solid, or this is also known as material damping. Solid or material damping, this is another way of damping. Guys, materials are elastic in nature. So if a particular material is absorbing some energy, and it is undergoing into some kind of deformation, that is known as solid or material damping. So in solid or material damping, material is going to offer some resistance by undergoing into some kind of deformations. Okay, that's why these kind of deformations, these kind of damping are known as solid or material damping. So there are many ways by which we can provide damping. Viscous damping, by moving a body in some kind of fluid. Direct surface to surface contact, dry friction or column damping. Solid damping, the resistance offered due to the elastic deformation or of a particular material. Okay, solid or material damping. There may be magnetic damping also. By producing some kind of magnetic field, you can offer some kind of resistance to the vibration. So there are many ways to produce offer some kind of resistance to the vibration. Those are known as damping techniques. So for this question, The vibration system slides on a dry surface that is known as a column damping guys. चलिए next question में move करते हैं. Question number 5. Next question guys in front of you. Question number 5 in front of you. A vibrating system has a spring of stiffness this. So spring stiffness is given to you guys. Let me write it here. Spring stiffness K equal to 32 Newton per meter. Mass is given to you 2 kg. The system is having a damper. Damping coefficient is given to you guys. C is given to you. C is how much? C is 8 Newton second per meter. This is the damping coefficient guys. This is known as damping coefficient. Okay, now what is asking you? The given system, the damper is there. The given system is a overdamped system, underdamped system, okay, or critically damped system. How to check that, guys? How we actually need to check this? You know, there is a factor which is known as zeta or damping factor. Okay, this is known as damping factor. Damping factor. Okay, this is nothing but this is a ratio of the damping coefficient to the critical damping coefficient. C by Cc. The ratio of damping coefficient to the critical damping coefficient, that is known as damping factor. And you know guys, if this damping factor is greater than 1, this is known as overdamped. Okay, if this factor is less than 1, this is known as underdamped. Okay, and if this damping factor is equal to 1, then this is known as critically damped. Critically damped. Critically damped means when C becomes equal to Cc, the damping which you are offering, that is equal to C equal to Cc. Okay, and one more thing guys, you need to remember, this C critical damping coefficient is nothing but 2m omega n, where m is the mass, wn is the natural frequency. So 2m omega n. And what is this omega n guys? Omega n is nothing but 2m under root k by m. Okay, so if you will take m inside, this will become 2 under root km guys. Just remember, you can remember either by this way, Cc equal to 2m omega n, or you can remember by this way, 2 under root km, where k is the stiffness of the spring, elastic, that is representing the elastic nature, m is representing the mass. So by putting all these things, easily you will get the Cc. Now let us try to find out the Cc guys here. So Cc equal to 2 under root km. So if we'll put it here, this value, how much is K? Stiffness is given to you 32. How much is mass guys? Mass is 2. So this will become 64. 64 means 8 square. So this will become 16 guys. Cc you are getting 16. Okay. Cc you are getting 60. How much is damping coefficient? It is 8. How much is Cc? It is 16. So ratio is 0.5. So damping factor for this case is 0.5 and it is less than 1. It means definitely it is a case of underdamped system. Means many ways he can ask you many ways. Like he can ask you, in this case the motion will be periodic, or motion means some kind of aperiodic motion you are going to get, or some kind of periodic motion you are going to get. So in this case, because the case is underdamped, so some kind of motion may be vibratory, some kind of vibrations you are going to get. Critical damp and what you can say overdamped system, there will be no motion, there will be no periodic motion, aperiodic motion you are going to get. Okay, or what you can say, in this case the motion will be vibratory, because the gradually the amplitude of the vibrations are going to decrease. Gradually amplitude is going to decrease. Okay, but you will have some kind of vibratory motion here in case of underdamped, but in case of critical or overdamped system there will be no vibration. Are you getting guys? And he can ask you about the zeta value, like what value of zeta you are getting, or third case he can ask you the system is overdamped, underdamped or critical damped. So as the zeta is coming out less than 1, means it is a case of underdamped system. So B is the right answer for this question. Very good guys, those are answering B. Overdamped Devansh, sorry, Divyash Patil. Ashish, your answer is right. Okay, Divyash, your answer is not right. Overdamped is not right. Underdamped is the right answer for this question. Guys, only 2 answers I am getting. What other students are doing? Please try each and every question, guys. Next question in front of you. A body starting from rest moves in a straight line with this particular equation given to you, S equal to 2t cube minus 3t square plus 2t plus 1, where S is representing the displacement guys. This is representing the displacement. So question is very simple. M is displacement in meter, T is the time in second. He is asking you the acceleration after 1 second. Very typical simple question. What will be the acceleration after 1 second? Guys, what is velocity? Or velocity is x dot. Let me write it here s dot, because here we are representing displacement by s. So this is nothing but what? Dx by dt. Okay, dx by dt, or here you can write it as ds by dt. Okay, rate of change of displacement. So if you will differentiate this, you will get a 6t square minus 6t plus 2. So this is the velocity. Guys, what is acceleration? Acceleration is nothing but d2x by dt square. Further, again, if you will differentiate this, you will get the acceleration. So acceleration we represent in vibration by x double dot. So this is 12t minus 6. This is the acceleration. Now he is asking you the acceleration after 1 second. Acceleration after 1 second. So just put this time 1 second. So 12 minus 6. 6 is the acceleration meter per second square. So answer will be what, guys? 6 meter per second square. Option A is the answer for this question, guys. Very good. Those are answering A. They are very, very right for this question, guys. Very good. Chaliye, let us move to the next question now. Question number 7th in front of us. Another typical question asked in various examination. He is going to give you some equation. You know, guys, the vibrational equation in case of linear vibration, linear motion, we represent it like that: mx double dot plus kx plus cx dot equal to 0. Okay, actually this we are getting from the Newton's second law of motion. The algebraic sum of all the forces in the direction of displacement, that is equal to the product of mass into acceleration. So mx, mass into acceleration, that is equal to algebraic sum of all the forces. Actually, if you will take a kind of simple spring mass system, something like this, and then if you will take it here a case, this is having spring stiffness k, this is having damper coefficient c, and then if you are having here some mass, okay, and you are displacing that mass by x, so easily by balancing all the forces, okay, because here this is the spring force which is going to act upside kx, the damping force is also going to act upward, okay, cx dot is a damping force, this is the spring force, and algebraic sum of all the forces in the direction of displacement, that is equal to the what? Mass into acceleration. That's why you will get this equation by Newton's second law of motion. Okay, mx double dot plus kx plus cx dot equal to 0. Okay, now if you will check, compare this and this equation, guys. अगर आप इस equation को compare करें, very clearly you can write it here. Sir, mass is given to us 4, stiffness is given to us 16, c is given to us 9. Very clearly by equating this and this, you can here check mass is 4, mx double dot plus cx dot plus kx, that is equal to 0. So now what is asking, guys? He's asking the critical damping coefficient. So earlier we had discussion. Critical damping coefficient is nothing but 2 under root km. Just put all the values. 2 under root. How much is k? 16. This is 9. So this is 2 into 4 into 3. So this will be what, guys? This will be 24. Okay. Just check it out. मैंने ठीक किया इसको नहीं? Yes. Just check it out. हाँ. Critical damping coefficient. He is asking you the critical damping coefficient. Critical damping coefficient of the system, guys. Yes. So K is given to us 16. So 2, 16 into 9. Yes. This is very correctly I am writing. Please check it out. Okay. 4 and 3. 4, 3. Yes. Okay. एक बार वैसे पुट करते हैं इसको. Let me again try. So cc equal to 2m omega n. So this is 2m under root k by m. So mass is how much? 4 into under root k is what? K is 16 divided by 4. This is 4. Okay. So I think we made some mistake here. Just check it out. So this will be 2. Yes. So this will be 2. Just check it out. 2m omega n. So 2m under root k by m. So 2 mass is 4. K is 16. Mass is 4. So 4, 16 divided by 4, you will get 4. Under root 4, you will get 2. So 2 into 4 into 2, the answer will be 16. So guys, D is the answer. Please check it out. The critical damping coefficient, yes, the critical damping coefficient is 16. Okay, very clear, very good. Cc equal to 2 under root km. Actually, k is given to us, 16. Okay, but mass is what? Mass is 4. Mass कितना है बच्चों? 4 है. So that mistake actually we did it earlier. So this is 4 into 2. So you will get 16. चलिए बच्चों, I hope this question is very much clear. D is the right answer for this question. Please check. Next question in front of you guys. Which is the equivalent stiffness of the system shown in figure? Guys, there is a system shown in figure. He is asking you the equivalent stiffness. आपसे क्या पूछ रहा है बच्चों? Equivalent stiffness. Guys, there are two cases actually. We can consider the springs, the elastic behavior of the body is in series or parallel. Guys, let me tell you, there is a case of springs in series. This is first spring, this is another spring. When you will say these springs are in series, guys, these springs are in series if they are subjected to the same load. The load acting on this is same mg, the load acting on this is also mg, both are subjected to same load. Okay, and the total deflection in this case, the total deflection of the mass is nothing but the deflection of spring 1. This is having deflection delta 1, this is having deflection delta 2. So total deflection of the mass is delta 1 plus delta 2. So you will say that springs are in series if total deflection is delta 1 plus delta 2 and both the springs or number of springs, they are subjected to the same load. Okay, so what is delta total, guys? This delta total, deflection total, this you can write it as because you know stiffness is nothing but load per unit deflection. So deflection is nothing but load by k. Okay, so this you can write it as mg divided by k equivalent. Further, you can write it as mg divided by k1. This you can write it as mg by k2. Yes or no? The deflection of spring 1 is mg by k1. Same load, W is acting. The stiffness is k1. The deflection of spring 2 is mg by k2. The load is same, but deflection will be different, delta 2. Okay, so if you solve this, what you will get, guys? You will get the formula. This particular formula you are going to get 1 by k equivalent equal to 1 by k1 plus 1 by k2. Just remember, guys, this is the formula to find out equivalent stiffness in case of series. Equivalent stiffness in series. If you are having springs in series, guys, and you want to find out the equivalent stiffness, just use this formula. Okay, guys, in case of parallel combination, the load acting on the springs will be different. Like suppose this is first spring, this is second spring. Okay, and they are connected to some load. Okay, they are connected to some load, something like this. So this is having stiffness, this is having stiffness k1, this is having stiffness k2. Similar to here, this is having stiffness k1, this is having stiffness k2. Okay, and this is the mass. So in this case, the load shared by this will be different. Load shared by this will be different because you are having springs in parallel. So they are not going to share the same load. Some part of the load shared by this, some part of the load shared by this, and the total load shared by this and this, what you can write it here, the load shared by this is suppose W1, the load shared by this is W2, and that W1 plus W2 is equal to the total load. Okay, but in this case, the deflection will be same, guys. The deflection of spring 1, that is equal to deflection of spring 2. Okay, the deflection will be same. Okay, now how you can write the deflection, guys? Again, how you can write the deflection? Deflection कैसे लिखोगे? Deflection will be what? This will be again, you can write it as W1. This is W1 divided by K1, and this is equal to what, guys? W2 divided by K2. Yes or no? Okay, and what is total W, guys? Total W is W1 plus W2. So if you want to make some kind of equivalent system of this, अगर आपको इसका कोई equivalent system बनाना है, so this is having equivalent spring which is also subjected to same load W. So the equivalent system is having subjected to same load W, and that equivalent system is having stiffness K equivalent. So this W will be what, guys? This W will be what? This you can write it as because stiffness K equal to load per unit deflection. So this you can write it as deflection stiffness K equivalent into deflection delta. Deflection will be same whether you are having one spring, second spring, or a equivalent system. So K equivalent into delta, that is equal to K1 into delta plus K2 into delta. So delta delta is same in case of springs in parallel. That's why the equivalent stiffness in parallel will be K1 plus K2, guys. So this is the way actually you need not to do this exercise again and again. Directly you need to remember, for the case of springs in parallel, the equivalent stiffness will be stiffness 1 plus stiffness 2, that there some will be the equivalent stiffness. But if you're having springs in series, then the equivalent stiffness will be this, guys. Then you need to use this formula to find out the equivalent stiffness in case of series. That is very, very important formula. You need to remember springs in series, springs in parallel, how to find out the equivalent stiffness. I hope this is very much clear to you. Now here, if you will check, guys, they are having the same deflection. Like suppose, let us consider this is deflected by delta, the deflection in this will be same delta. Okay, but the load shared by them will be different. So this is a case of what? Parallel. ये किसका case है बच्चों? This is not a case of series, this is a case of parallel. This is a case of parallel. Now in parallel, the equivalent stiffness will be what, guys? The sum of this. So this is having stiffness 8, this is having stiffness 16, so the sum will be 24. A is the answer, guys. 16 plus 8, 24 is the equivalent stiffness. Very good. This is a case of parallel. So in parallel, the equivalent stiffness will be K1 plus K2. So 8 plus 16, the answer will be this. Okay. Guys, let me tell you one more thing. Because sometimes you are going to face some question. There is a spring and you are kind of dividing that spring into some two parts. Okay. Just remember, guys, if you are having a spring, suppose you are having a spring and you are cutting into two parts. You are having a spring, you are cutting into two parts, the stiffness is going to increase. If number of turns are more, the stiffness will be less. If number of turns are less, the stiffness will be more, guys. So if you are dividing, if you are cutting a spring such that number of turns are going to decrease, the stiffness will increase. So just remember, if a spring is having stiffness K and you are dividing it to two equal parts, then the stiffness of the equivalent parts will be what? 2K and 2K. The upper part will have stiffness 2K, the lower part will also have stiffness 2K. If you are dividing a spring into two equal parts. Otherwise, if you are dividing a spring into some ratio, guys, अगर मान लीजिए the number of turns on the springs, number of turns are 8 and you are dividing this spring into something like this, 5 turns and 3 turns. You are dividing the spring in two parts such that 5 turn spring is one, 3 turn spring is second. Now, which spring will have more stiffness? This upper one or lower one? Guys, can you tell me? There is a spring which is having total number of turns 8. There is a spring which is having total number of turns 8. Now you divided that spring into two parts. One containing number of turns 5, the second containing number of turns 3. Which one will have more stiffness? Lower one. Very good, guys. This lower one will have more stiffness. Lesser the number of turns, more will be the stiffness. Okay. So you can use some formula here. M plus N divided by M into K. Okay. M plus N divided by N into K. So this I'm writing it as ratio of Mn. Okay. I'm writing it as a ratio of Mn. So this is M into N, M ratio N. So upper part is M, lower part is N. So upper part stiffness will be M plus N divided by M into K. It means it will be 5 plus 3, it will be 8 by 5K. Okay. And it will be 8 by 3K. You can check it here. The stiffness of the lower part will be 8 by 3K. It is more, and the stiffness of the upper part is 8 by 5K. Now, if we will ask you, like you are having a spring, okay, you cut it into two parts and then again joined in series. Then what will be the stiffness? What will be the equivalent stiffness? So then again you need to think, you need to solve that case. If there is a spring, you are dividing and then you are arranging those dividing parts in series or parallel, then he is going to ask you. Yes, very good, Abhimanyu. The stiffness will be same. You divide it and again you join. So number of turns are what? You divide it into 5 and 3 and again you join. Number of turns are again 8. So stiffness will be same K. Otherwise you can use the formula and you can find out the case, it will come out same K only. Okay. So these kind of questions you are going to face. Now there is a one question in front of you. A simple spring mass system has a natural frequency of N. If the spring stiffness is halved, then the mass doubled. Stiffness halved, mass doubled. So omega n is n. This is omega n1. Okay, omega n1. This is under root k by m. Under root k by m. This in first case the natural frequency is n. Now what you did, guys? You increase the mass. You halve the stiffness. Spring stiffness is halved. So this is k by 2. Okay, and mass doubled. Mass doubled. So it will become what, guys? It will become 1 by 2 under root km. And what is this k by m, guys? This is nothing but n. So the natural frequency will be n by 2. So the answer will be A, 0.5 n. Fine, guys. The natural frequency will be 0.5 n. A is the answer for this question. Please check this question. A spring mass vibrational system has a natural frequency n. So natural frequency is given to you under root k by m. Okay. Now he's saying the stiffness is halved, means k becomes k by 2. Mass becomes doubled. Mass becomes 2 times. So this is under root 4. Bahar logoge to it will become 1 by 2 under root k by m, and under root k by m is nothing but n. So n by 2, answer will be 0.5 n. Okay, chaliye, let us move to next question. Question number 10th in front of you. Okay, chaliye. So there is a helical compression spring of stiffness k is cut into 2 pieces, each having equal number of turns. Each having equal number of turns. Guys, there is a spring having stiffness k. You divide it into 2 equal parts, means both will have stiffness 2k and 2k. Now, kept them side by side under compression. Side by side means what, guys? Side by side means in parallel. So this is first spring. This is second spring. You kept them under compression. So this is having stiffness 2k, this is also having stiffness 2k, and this is a case of parallel. So in parallel, equivalent stiffness will be k1 plus k2. Because this is a case of parallel, so the equivalent stiffness will be 2k plus 2k. The answer will be 4k. तो आंसर क्या हो जाएगा बच्चों? ऑप्शन ए अगेन 4k is the right answer. Please check. Very good, guys. So here what he has given you, there is a spring, you divide it into 2 parts, so stiffness becomes what? Double, 2k 2k, and now you arranging those springs in side by side, means in a parallel arrangement. So in parallel the equivalent stiffness is k1 plus k2, so 2k plus 2k, the answer will be 4k. Let us move to next question 11. A 20 kg mass is suspended from a spring which deflects 15 mm under its load. Guys, the deflection of a spring under its load, that is known as static deflection. So this static deflection is given to you. This is static deflection. So this is 15 mm. The value of the critical damping coefficient to make the motion aperiodic. Okay. The value of the critical damping coefficient. So he's asking you the value of critical damping coefficient. Okay. The value of critical damping coefficient, so the motion becomes aperiodic. So how you will solve this, guys? You know, Cc is nothing but 2m omega n, and guys, this omega n is nothing but under root g by delta, where this delta is known as static deflection. Omega n you can write it as under root k by m also, but this you can write it as under root g by delta also, where g is the acceleration due to gravity and delta is the static deflection. Okay, now if you put it here, all the values, 2 into mass, how much is the mass? 20 kg. Under root g is 9.81. Static deflection is 15 mm, so 15 into 10 to the power minus 3. Okay, so if you solve this, you will get the answer. Some calculation is required. This is previous year question of one of the examination where there is no calculator given, no calculator allowed. So you cannot ask me, sir, why, how to solve this. That you need to think, you need to try. Okay, please do the calculation and tell me what answer you are getting. I'm giving you some time, please try. Okay, so guys, if you solve this, if you are getting this answer, although all answers are very close, 1010, 1018, 1013, but this will come out. D is the right answer. Please check. 1023. Very good, Ajay. Next question in front of you, question number 12. So there is a vibrating system consisting of mass 50 kg, spring of stiffness 30 kilonewton per meter, and a damper. The damping is 20% of the critical damping, guys. So C equal to 0.2 of cc. So indirectly what he is giving you guys, he is giving you c by cc equal to 0.2, means this is nothing but zeta. Okay, so zeta he has given you the critical damping factor, zeta is given to you 0.2. The ratio of c by cc is 0.2, because clearly he has mentioned the damping is 20% of the critical damping. So c equal to 20% means 20 by 100. How to convert percentage into fraction? 20 by 100. So 20 by 100, 0.2 into cc. So this is the damping coefficient. Okay, now what is asking you? Is asking you the damped natural frequency. Guys, there's a formula in case of under damped system, because in that case only you are going to get the motion. Okay, otherwise in case of critical damped or under over damped system there will be no motion. Okay, so in case of under damped system there will be motion, and that damped natural frequency is asking you. What is that, guys? This is under root 1 minus zeta square into omega n. That formula you need to remember. Omega d, damped natural frequency, that is equal to under root 1 minus zeta square into omega n. Now if you put it here, under root 1 minus 0.2 square into omega n. How much is omega n, guys? Omega n is under root k by m. Under root k, so k is 30 into 10 to the power 3 divided by m. How much is m? This is 50. Okay, so further you need to solve, you need to carry out the calculation. So this is something like a plus b. A plus b, you can write it as 1.2 into 0.8 into 30 into 1000 divided by 50. Okay, just carry out the calculation. 1.2 into 0.8 into under root 30 into 20. Further, if you solve this, guys, this you can write it like something like this: 12 into 8 into 3 into 2. Okay, so इसको मैं लिख सकता हूँ 4 into 3 into 4 into 2 into 2. This I'm writing it as 4 into 3. This is 4 into 2 into 3 into 2. Okay. So further, if you solve this, this is what? This is 4 square. This is 3 square. This is 2 square. So you will get 4 into 3 into 2. So answer will be 24 radian per second. 24 radian per second. Okay. Chaliye, so for this question, the answer will be 24 radian per second. Option C is the right answer. Please check the damped natural frequency. Damped natural frequency. Next question in front of you, question number 13. Let me put it here. Again, a kind of, question which is asked in any examination, PSUs, and even in engineering services also this question was asked. So there is, as compared to time period of a simple pendulum, there is a pendulum which is having some time period on earth. What will be the time period on moon? Okay, guys, what is time period, guys? Is asking you, as compared to the time period of a simple pendulum on earth, what will be the time period on moon? So very simple question, guys. Omega for a simple pendulum is nothing but under root g by l. I told you omega n, natural frequency of a simple pendulum, is under root g by l, where l is the length of the string, something like this. So this is l. Okay, now omega equal to what? This is 2 pi f, or this is nothing but 2 pi by t. So time period is nothing but 2 pi by omega. Okay, or you can write it as 2 pi under root g by l, or it is nothing but 2 pi under root l by g. So directly you can remember. It is better to remember this only, guys, because if you are able to remember this, omega n for simple pendulum is under root g by l, this easily you will be able to get this in seconds. You will be able to write this time period equal to time taken to complete one cycle, that is 2 pi under root l by g. Okay, now The same pendulum you are checking on Earth also, Moon also. There is no change in the length. But guys, how much is the acceleration due to gravity on Moon? Acceleration due to gravity on Moon is 1/6 of the acceleration on Earth. G on Moon is G by 6. Okay, so now if you'll put it here, this is the time period on Moon. Time period on Moon. So this is the acceleration on Moon. Acceleration due to gravity. So this is 2 pi under root L by G by 6. Okay, so this will be what, guys? 6 will be go up above. So this is 2 pi under root L by G into under root 6. So what is this, guys? This is the time period on Earth. This particular term 2 pi under root L by G, this is representing time period on Earth. So time period on Moon is going to increase. So that becomes what? Under root 6 times of the under root 6 times higher or lower, guys? The time period is increasing or decreasing? So there are very good options given: 6 times higher, 6 times lower, under root 6 times higher, under root 6 times lower. So time period is going to increase. Time period क्या हो जाएगा बच्चों? It is going to increase and it will be under root 6 times higher. So C is the right answer, guys. So those are answering option C. They are very, very right. Very good, Pappu, Abhimanyu, Aditya. Guys, your answers is very right. एक बच्चे ने और आंसर किया है, मोली. Very good, guys. The C is the right answer for this question. Let us move to the next question now. Question number 14 in front of you, guys. While calculating the natural frequency of a spring mass system, the effect of mass of the spring is accounted by adding a factor x. It's the value of this x will be. Guys, you know, if you are having a spring mass system, something like this, so this is spring, this is mass. So without considering the mass of the spring, the natural frequency is given by under root k by m. But with considering the mass of the system, suppose this spring is having mass ms. Ms is the mass of the spring. So in that case, Wn will be under root k by m plus ms by 3. Just remember this formula, guys. Wn equal to k by m plus ms by 3. This is what natural frequency considering mass of the spring. Considering mass of spring. Okay. So now what he is asking you? He is asking you the spring mass is accounted by a factor x. What is that x, guys? What is that x? That x is nothing but 1 by 3. The mass of the spring is, you know, is multiplied, is accounted by adding some factor x. That x is nothing but 1 by 3. So B kya ho jayega? B is the answer for this question. Let us move to next question, guys. Question number 15. Question number 15 in front of you. So large field guns which comes to initial position after firing in shortest possible times are large field guns, okay, which comes to initial position after firing in shortest time are underdamped, critical damped or overdamped. Guys, in case of critical or overdamped, in both the cases the motion will be aperiodic. But what is the difference? If I'm taking a case of what zeta 0 means no damping, I'm taking a case of no damping. No damping. बच्चों अगर damping नहीं है, the amplitude is going to remain same. Whatever amplitude you are having here, the same you will get here, the same you will get here, the same you will get here. So amplitude is not going to change. Amplitude is not going to change. Means no damping means no friction. No friction, no resistance. No resistance to vibration. No damping, no friction, no resistance to vibration. The amplitude is going to remain same. Okay. Now, if you're having a case of some kind of underdamped system, so in underdamped, the amplitude is going to decrease gradually. It is going to decrease something like this. It is going to decrease something like this. So it is going to decrease exponentially, something like this. The amplitude will decrease exponentially. ये exponentially क्या करेगा बच्चों? It is going to decrease, but the motion will be aperiodic. Now, if you're having a case of what? A case of overdamped or critical damped system. So if you're taking it here, x versus time plot. So these all are x versus time plot, guys. This is x displacement versus time plot, displacement versus time plot. This is for no damping. zeta 0. This is for what? Zeta less than 1, under damped. This case 1 is for no damping. Case 2 is for under damping. Okay. Case 3 and 4, I'm showing it here on the common page. So some kind of plot you will get it here for critical damped, and for over damped you will get it here something like this. So this is for zeta greater than 1, and this is for zeta equal to 1. So it is observed in case of critically damped system, the body is going to take the least time, shortest time the body is going to reach to its equilibrium condition, it's going to reach to its initial position. So, and that is required, because if you want to fire, okay, some kind of gun you are firing, so you require, yes, the gun is going to reach to its initial position in the minimum time, so that next fire you will be able to carry out. Otherwise आपका जो निशाना होगा, that maybe will not be good. Okay, so yes, field guns, they are designed at with the critical damp so that they will reach to their initial position in the shortest time possible. 16th question, guys, in front of you. 16th question. When shaking force is transmitted through the spring, the damping becomes determinantal when the ratio of the frequency to the natural frequency is greater than. This question is good, guys. Very good question. There is a term which is known as transmissibility, force transmissibility. Force transmissibility. Okay. This is nothing but it's a ratio of the force transmitted to the force unbalanced force applied. So this is the ratio of the, like suppose we attach some kind of isolations just to restrict the, what you can say, the force transmitted to the foundation. Like suppose if you are having a machine that is vibrating, suppose there is a lathe machine you mounted on some ground, so vibration is not the problem of system, the vibration is the problem of system as well as surrounding. Like suppose there is a machine, you designed it very properly, there are no vibration in that machine, but that machine is placed nearby to some machine which is having huge vibration, which is having huge unbalanced forces in that. So that machine is very good, you designed it very accurately, but its nearby machine is vibrating, so that there will be some vibration will enter into that machine also. That's why some kind of isolations we provide always to restrict the transfer of vibrations from machine to the foundation. Because if vibrations are going to the foundation, then surely whatever is there on that foundation, any other machinery or any other component, that is also going to vibrate. Okay, so there is a term which tells us about the effectiveness of the isolation. How effective is the isolation? That effectiveness of the isolation is measured by one parameter that is known as force transmissibility. Okay, or that is known as transmissibility factor. Transmissibility factor or force transmissibility, that is the ratio of the force transmitted to the foundation to the total force applied. Okay, now here if you check it here, यहाँ पे एक चीज आप ऑब्जर्व करोगे, if you are taking it here a case versus transmissibility ratio, force transmissibility and omega by omega n ratio. Now if you take it here some ratio, suppose this is 1, this is under root 2. Okay, so here the omega by omega n is 1 and this is, and here you can have different plots, something like this. So this is a kind of plot for zeta 0, no damping. This kind of plot you are going to get. For zeta less than zeta greater than 0. Okay, again some kind of plot you will get it like this. Let me take another curve, something like this. Just observe it here, guys. This point you need to observe it here. So let me join this also. Let me join this also at here, something like this. Okay, now you need to observe it here very carefully. So this is green one, and yes, this is the black one. Now these are the different cases, guys. For suppose this is zeta 0.2, black one is what? This is zeta 0.4. Okay, and suppose this is we are having green one, we are having 4 zeta, this is for zeta 0.8. Okay, and here if you check it here, This is zeta 0.8, guys. So when at here at point 2, they are going to merge actually. These lines, they are going to merge at omega by omega and under root 2. Okay, so there is one formula, you can write it here for the force transmissibility, and if you write that easily, some idea you will get from that. Let me write it here in front of you. So force transmissibility, this is under root 1 plus 2 zeta omega by omega n square, 1 plus 2 zeta omega by omega n square, divide by under root 1 minus omega by omega n square whole square plus 2 zeta omega by omega n square. So this factor, actually this ratio we are having for the force transmissibility. Okay, this factor we are having for force transmissibility, and here if you will check it guys, if this zeta is 0, अगर आप यहाँ पे check करोगे, if this zeta is 0, okay, अच्छा, this will be inside the bracket guys, this will be inside the bracket, let me write it here, this will be inside this 2 zeta omega by omega n square. So if you check it here guys, if zeta is 0, zeta 0 means there is no damping. Okay, so if there is no damping, this zeta will be 0 and this term will be 0, and here this term will also be 0. If zeta is 0, no damping, so this will be 0. Now if there is no damping, and if this omega by omega n, this term guys, if this term omega by omega n, this is equal to under root 2. So if this is under root 2, what is under root 2 square? You will have 2, that is 1 minus 2, that is minus 1. So minus 1 square, you will get 1. Further under root of 1, that is 1. So if omega by omega n is equal to under root 2, the transmissibility will become 1. So whatever is the unbalanced force, that entirely will be transmitted to the foundation. Okay, but if you will observe it here, if this omega by omega n is greater than under root 2, if this is greater than under root 2, then if more is the damping, more will be the transmissibility. If less is the damping, less will be the transmissibility. That's why this under root 2, this ratio of omega by omega n, if this becomes more than under root 2, if this becomes more than under root 2 guys, the vibration, the damping factor becomes determinantal, because if damping factor is more, the transmissibility will be more, and if damping factor is less, here you can check it here the damping factor is less. Okay, यहाँ पे damping factor क्या है? Damping factor क्या है? ज़्यादा है, but transmissibility is more. Here for the blue color, the damping factor is less, but the transmissibility is less. That's why at this, the transmissibility will be more. Two important results you need to remember. The transmissibility will be equal to 1 when the omega by omega n ratio is under root 2. The transmissibility will be infinite if omega is equal to omega n. Agar ye omega n both are same, means if this ratio is becoming 1, then 1 minus 1, you will have what? This will be what? 0. So no damping and omega by omega n is 1, the transmissibility become infinite. You can check this line guys. This line you can check. This is going towards infinite. Okay. These are very important conclusion you need to remember. Transmissibility is the ratio of the force transmitted to the foundation to the applied force. This we require less than 1 guys, because if this is more, transmissibility is more, means more force is transmitting to the foundation. Okay, so means isolation is not working effectively. So if this omega by omega n is 1 and with no damping, the transmissibility will be what? It will be infinite. And if this omega by omega n is under root 2, then the transmissibility will be 1 irrespective of any zeta value. You can check it here guys. This value is under root 2, so this value becomes 1. So 1 plus 1, numerator denominator both are same irrespective of any zeta value, whether you are having zeta 0.2, whether you are having zeta 0.54, whether you are having zeta 0.8, all are going to give that transmissibility what? 1. So let me write it here, this particular line. तो ये जो line है बच्चों, this is representing what? Transmissibility 1. So this is transmissibility 1. Okay, so this is 1 guys. So here transmissibility become 1 irrespective of any damping factor. But if this ratio omega by omega n is greater than under root 2, then the more is the damping, more will be the transmissibility. Less is the damping, less is the transmissibility. That's why if this omega by omega n is greater than under root 2, it is good to keep the less damping, so that transmissibility will be what? It will be less. Chaliye. So answer for this question is what? Under root 2. I have given you some additional information, guys, related to this force transmissibility. I hope this is very much clear to you. Okay. Chaliye, now let us move to the next question, question number 17. Please read it and try to answer this question. When the mass of a critically damped single degree of freedom system is deflected from its initial position and released. Guys, the system is critically damped. The system is critically damped, and critically damped, the motion is aperiodic. There is no motion you are going to get. So there will be any oscillation in case of critically damped. Guys, in case of critically damped and over damped, there is no oscillation. The oscillation will be there in the case of under damped only. So that's why what will be the answer, guys, for this case? The system will return to its equilibrium position without any oscillation. Guys, in case of critically damped, there will be no oscillation. But in case of under damped, there will be only oscillation. Under damped में oscillation आएगा, but in case of critically damped or over damped, there will be no oscillation. So it will return to its equilibrium position in the minimum time without any oscillation. Next question in front of you, guys. Consider the following statement. There is a question related to critical or whirling speed of a shaft. So the question is, the whirling speed of a shaft is that rotational speed at which the shaft so runs that the deflection of the shaft from the axis of the rotation tends to become infinite. Yes, very good, very right. Because whirling or critical speed is that speed where the omega becomes equal to omega n. Omega becomes equal to omega n. Okay. This is that natural speed where the huge violent vibrations are going to induce in the body. Okay, very violently the shaft is going to vibrate. That speed at which huge violent vibrations are going to induce in the shaft, those are known as, that is known as critical or whirling speed of the shaft. Okay, so this is very right. This statement is very right. The critical speed is equal to the frequency of transverse vibration of a shaft. Guys, critical speed or whirling speed is nothing but under root g by l, where g is the acceleration due to gravity, g by static deflection, g by delta st, where g is the acceleration due to gravity and delta st is the static deflection. Okay, so critical speed is equal to the frequency of transverse vibration of a shaft when the shaft carries a point load or a uniformly distributed load or a combination of both such load. Is it right, guys? Okay. The whirling of a shaft results from causes such as mass balance, unbalance, hysteresis damping in the system, gyroscopic force, and fluid friction in the bearing. Whirling of a shaft results. Guys, whirling क्या होता है? Let me tell you some basics about that, guys. Actually, if you will take a case like suppose there is a shaft, okay, and suppose there is some weight attached, some pulley is there, okay. Now, guys, due to some kind of metallurgical or manufacturing difficulties, sometime it is observed the center of mass of the shaft, center of mass, okay, center of the mass, it displaces from the central axis. Okay, so the distance between the center of mass and the central axis, that is known as eccentricity. Okay, and further, when it is going to rotate, some kind of centrifugal force is going to act, that is m. That will be what? That will be E, plus when it is going to rotate, some additional deflection you are going to get, guys. Okay, some additional deflection we are going to get, that is Y. So Y is the additional deflection we are going to get. So M E plus Y omega square. Okay, so huge, and actually these centrifugal force, these are actually cumulative in nature. More is the speed, more will be the centrifugal force. More is the centrifugal force, more will be the Y. So these are cumulative in nature. As you are going to increase the speed, the centrifugal force is going to increase and Y is also going to increase. Additionally, there will be additional centrifugal force. Again, Y will increase. So if there is a kind of unbalance is there in a shaft, the mass is not at the central axis, then Some cases at some speed, the violent huge vibrations are going to induce in a shaft. That speed is known as critical or whirling speed of a shaft. Now try to answer this question, guys. Try to answer this question. ओके, चलिए तो this is very right, the whirling or critical speed of the shaft. Now if you read the second part, critical speed is equal to the frequency of transverse vibration of a shaft when the shaft carries a point load or a uniformly distributed load. Guys, critical speed is equal to the is that speed when it will match with the natural frequency omega equal to omega n, and that depends on what g by delta st. And if you write it here, if you will take a case of what a shaft carrying some point load at the center, a shaft carrying some point load at the center. So what will be the static deflection, guys? Static deflection will be WL cube by 48 EI. Okay, you know, there is a shaft carrying some point load at the center. The static deflection will be WL cube by 48 EI. So natural frequency or the critical speed is nothing but under root G by static deflection, which is WL cube, and this you can write it here 48 EI. So this is the critical or whirling speed. Okay, it is not going to depend on what. This is not the frequency. Okay, critical speed is the natural frequency where omega becomes omega n. So this is not right. The whirling of the shaft results from the cause such as mass unbalance. Very right. High surface damping, and yes, some kind of gyroscopic forces or fluid friction also in the bearing that can induce some kind of whirling of shaft. So this is also right. So 1 and 3 are right. So for this question, B is the right answer, guys. So those are thinking about B, they are very right. B is the right answer for this question. UDL is also possible, okay, but in shaft actually, because shaft, over the shaft what you will have on beam, UDL may be there, but shaft is having some kind of pulley over that. So there must be some kind of point load you can consider over the shaft. Okay, let us move to next question, question number 19. Similar kind of question. Now what is asking you, the critical speed of a shaft depends on, mass, stiffness, mass, stiffness and eccentricity. The critical speed of shaft depends on, try to answer, guys. The critical speed of shaft depends on, किस पे डिपेंड करता है बच्चों? What is critical speed? When omega becomes equal to omega n, and this is nothing but g by static deflection. Okay, and for the case of shaft subjected to some point load at the center, this is nothing but g into 48 EI divided by WL cube. So if you'll check it here, the whirling speed or critical speed is depending on mass. Yes, it depends on the stiffness. Depends on the stiffness. Yes, it depends on the stiffness also. Okay, it is going to depend on the elastic nature, but it is not going to depend on the eccentricity. The centrifugal force, the amplitude of the vibration, that will be different. Okay, that is going to depend on the eccentricity, how much is the unbalance. But the critical speed or whirling speed is not going to depend on the eccentricity. That depends on mass and stiffness only. That's why for this question the answer will be C, mass and stiffness. The critical or whirling speed depends on mass and stiffness only, guys. The critical speed is independent of the eccentricity. Now let us move to the next question. The static deflection of a shaft under flywheel is this. G is this. What is the critical speed? Very simple, similar question. Easily you will be able to answer this question, guys. Omega equal to omega n, that is nothing but under root G by static deflection. So how much is G? Is giving you G 10. How much is the static deflection? The static deflection is given to you 4 mm. So 4 into 10 to the power minus 3. So this is 10,000 divided by 4. Okay. Yes. So delivered guys. 4 पे भेजोगे, इस पे 2 पे जाएगा 500. $50 will be the answer for this question, guys. Please check it out. Option A, 50 radian per second is the answer for this question. Please check the calculation. 50 radian per second is the answer. This is the critical or whirling speed in this case. Let us move to next question, question number 21. What is the magnification factor in case of steady state response when the frequency ratio is this? So guys, he has given you frequency ratio omega by omega n. This ratio is 0.8. Okay. Excitation frequency is less than the natural frequency, so omega by omega n is 0.8. The level of damping zeta is given to you 0.4. The level of damping zeta is 0.4. He is asking you what, guys? He is asking you the magnification factor. What is the magnification factor in case of steady state response? Guys, what is magnification factor? Two terms are very important. Transmissibility, magnification factor. Transmissibility is the ratio of the force transmitted to the foundation to the applied force. Magnification factor is the ratio of the steady state amplitude of the vibration to the static deflection. You know, guys, if there is a load applied, there must be some static deflection will be there in the shaft. So the amplitude of the steady state response to the static deflection, that is known as magnification factor. Okay, so this particular ratio, magnification factor, the amplitude of the steady state response to the static deflection, that is known as magnification factor. Okay, and how you can write it, guys? This is very easy, very simple to remember. You can write it as 1 by under root 1 minus omega by omega n square whole square plus 2 zeta omega by omega n. So this is the magnification factor, guys, we are having. Now you need to put all the values here. You need to put all the values here. 1 by under root 1 minus, how much is this ratio, guys? Omega by omega n, this is 0.8. So this is 0.8 square whole square plus 2 into how much is zeta? Zeta is 0.4 into 0.8 whole square. So if you solve this, guys, you will get the answer. Please try to solve and tell me what answer you are getting. Okay. Please solve and tell me what answer you are getting. Let me also check. You can also do the calculation, or you can try magnification factor, which is the ratio of the steady state amplitude to the static deflection. Yes. So if you are getting 1.36, your answer is very right, guys. 1.36 is the right answer for this question. 1.36 is very, very right answer for this question, guys. ठीक है? चलिए, next question in front of you, question number 22. A vibrating system with mass 3 kg, stiffness 21 Newton per meter, and a damper having damping coefficient 10 Newton second per meter, when an excitation force of 27 sin 2t is acting, what will be the time period of acceleration? बहुत अच्छा question है बच्चों. I will say this is very, very good question. Very good question, guys. Please try this question. There is only one simple concept involved. Guys, there are two type of frequencies: natural frequency or what? kind of excitation frequency, the frequency of the external force. So guys, when there is no damping in the body, no resistance to the vibration, and there is no external force acting, then the body is going to vibrate at its natural frequency. So the natural frequency is that frequency of vibration when there is no damping, there is no external force acting. But when there is some kind of external excitation is acting, then the body is going to vibrate at some frequency which is equal to the frequency of the external excitation. So in this case, he's asking you the time period. He's asking you that time period, and time period is very easy to find out, because here the W will be what? W will be this F naught, the external force. How we write external force, guys? F naught sine omega t. F naught sine omega t. So this is the external force. This is the magnitude. 27 is representing the magnitude of the external force, and this 2t is representing what? 2 is representing the frequency of the external excitation. So directly he has given you W, guys. W is 2. Now what is time period? Omega is 2 pi f, or it is nothing but 2 pi by t. So time period is nothing but 2 pi by omega. So this is 2 pi by 2. It means the time period is pi. Pi means it is 3.14 second. The answer will be what, guys? The answer will be C, 3.14 second. Okay. 3.14 second is the right answer for this question. Guys, देखो यहाँ पे आप क्या कर सकते हो? देखो आपको ट्राई कैसे करना पड़ेगा, हाउ टू ट्राई दिस काइंड ऑफ क्वेश्चन. देखो यहाँ पे अगर आप करते हो 1 by under root, this is what? This is a square minus b square, so you can write it as 1 plus 0.8 square into 1 minus 0.8 square, like this you can write. Okay, like this you can write, plus this is what? This is 2 into 0.4, this is 0.8, 0.8 into 0.8, so this is 0.8 square whole square, this is 0.8 square whole square, something like this. Further, if you will solve, this will give you what? Under root 1.8 square into 0.2 square plus 0.8 square. Okay, so like this you need to try. Further, you will be able to reduce this. आप इसको चाहोगे तो reduce कर पाओगे, because this you can write it as 0.36. अगर आप इसको multiply करोगे, this will be 0.36 whole square. Okay, so you will be able to reduce, and then accordingly you need to check, but definitely you will be able to conclude to some answer, because there is some specific gap is there, and easily you will be able to conclude some answer. Please try with that. So for this question 22, C is the answer. What I mentioned, guys, why I'm not considering natural frequency? Under the influence of the external force, body is not going to vibrate at natural frequency. Like suppose there is a lathe machine and some motor is attached over that. So whatever are the components, they are going to vibrate at the frequency of the external excitation. So forced vibration in case of forced vibration, the body is going to vibrate at the frequency of the external excitation. But if there is no external force, like suppose you are having a pendulum, you lift it and you remove the force. There is no external force acting. So body is vibrating without any external force. Body is vibrating due to its own elastic nature, without any damping, without any external force. That frequency is known as natural frequency. Okay, so here, because some external force is acting, the body is going to vibrate at what? The frequency of the external excitation. That is what W is 2 here. Then time period will be 3.14 second. Chaliye, next question in front of you guys, question number 23. Again, this is very good question, guys. Please try this question, very good question. 23. An undamped system having mass equal to 10 kg is to be isolated from sport vibration, where the natural frequency is this. So this is the frequency of sport vibration, means this is W, guys. This is W. W is what? 10 radian per second. This is not natural frequency. This is the frequency of the external excitation. So sport is vibrating. So some machine is mounted over some sport, and sport is vibrating at this frequency. So this is the frequency of the external excitation. W is given to you. Okay. Now the amplitude does not exceed 1/10 of the sport amplitude. So indirectly, what is given you? He is giving you this ratio, the ratio of the amplitude to the static deflection. What? This is magnification factor, and this is nothing but what? The amplitude does not exceed 1/10 of the sport amplitude. Okay, ठीक है. So this is what, this is 1/10 only guys. यहां पे अगर आप मैग्निफिकेशन फैक्टर करोगे, द सच दैट the transmitted amplitude does not exceed 1/10 of the sport amplitude. So magnification factor कितना है आपका? This is 1/10, this is 0.1. Magnification factor is 0.1. Now if you'll put it here, all these values, magnification factor which is 0.1, which is nothing but 1 by under root 1 minus omega by omega n square whole square plus 2 zeta omega by omega n square. Now check this. Undamped system. Guys, this point is very, very important. Undamped system. What is undamped? Undamped means no damping zeta 0. And if there is no damping zeta 0, then this term will be 0, guys. This term will be 0. So now further solving this, if you will take it here, you will get 1 minus omega by omega n square whole square under root. Okay, that is equal to what? That is equal to 1 by 0.1. Okay, that is equal to 1 by 0.1, and that is nothing but what? This is equal to 10. This is equal to 10. Yes, please check this. Please check this. Now you can solve this further. 1 minus omega by omega n square, that is equal to what? That is equal to 10. That is equal to 10. Further solving, you will get omega by omega n square, that is equal to 9. Yes, or omega by omega n equal to what, guys? That is equal to 3. Omega by omega n, that is equal to 3. Now if this is 3 omega by omega n, then what is omega n? Omega n equal to omega by 3, that is equal to 10 by 3. And what is this, guys? This is under root k by m. Under root k by m. Under root k by m. Okay, so you need to compare this and this. So what we did, guys? First, through this we got the idea. Magnification factor is given to you 0.1 because he is telling you the amplitude transmitted does not exceed 1/10 of the sport amplitude. So magnification factor is what? That is 0.1. Okay, now this magnification factor is 0.1, then the system is undamped. System क्या है आपका? Undamped है. So if this system is undamped, this term will be 0. Further, there is only simplification I carried out. So omega n becomes omega by 3. This becomes 10 by 3. That is equal to under root k by m. Further, if you solve it here, let me write it here. 10 by 3, that is equal to under root k by m. Further, if you will take square both side, so 100 by 9, that is equal to k by m. How much is the mass, guys? Mass is 10 kg. So the stiffness is 1000 divided by 9. एक बार चेक कर लेते हैं बच्चों. Guys, let me check it here. I think okay. Guys, one mistake is there. ये क्या है आपका? This is omega by omega n. Yes. This is 10. Fine. Just check it out. Just check it out because this I'm taking this side. So यहाँ पे ये गड़बड़ हो जाएगा because this is 10, guys. This is 10. This is 10. Just check it out. 1 minus omega by omega n, that is equal to what? That is equal to 10. Square both side kiya, so this will go this side. Omega by omega n square. So I think this will come out 11. Please check it out. Please check it out. Yes, or you can check it here. Yes, 10 by 9. So this is 9. So let me check this again. Please check. अगर हम इसको सोल्व करेंगे, it will come out more than 100. More than 100, but उसके साथ कोई ऑप्शन एग्जैक्ट नहीं है. Please check it again. The calculation. This calculation part, guys. Please check it again. 1 minus omega by omega n square equal to 10. Please check this again. I think I'm getting this only. I'm getting this only. Okay, let me check it again from the beginning. So this is 0.1. 0.1 equal to this. So yes, so this is under root this. Fine. This is 1 by 0.1. This is 10. So yes, that point is very right, guys. Very good. So when we are taking, no, actually what we did actually, यहाँ पे अंडर रूट नहीं रिमूव किया हमने. What you are thinking, guys, you are thinking, okay, I'm taking square both sides, it becomes 100. Guys, here you can check, this is under root and this is whole square. Under root whole square, that will cancel out. Or otherwise, if you want to take square both side, then it will become 100. But here what you will get? You will get 1 minus omega by omega n whole square. Square and whole square. Then the things become same only. So 100 nahi aayega, there will be 10 only, guys. Okay. So 1 minus omega by omega n square, that is 10. So omega by omega n square, that is equal to 9. Okay. So I'm getting this. Yes. 3. Okay. So guys, I feel this is right. There is no issue. There must be some error in this because this is not going to come 11. This is not going to come 11 because this is 1 minus and here you are having minus. This is not going to become 11. Agar ye 11 ho jata, then there are chances you will get this answer. Otherwise, you are not going to get this. Okay, so and I don't feel that there 11 will commit here. 9 is only going to commit here, and you will get some answer in the range of because this will go 1, then again 1, then again 1, something like this. Something like this, the answer you are going to get. Okay. हाँ वो हो सकता है, प्लस माइनस लगा सकते हो आप, बिल्कुल वो कर सकते हो आप, दैट यू कैन डू, बिल्कुल उससे हम चेक कर सकते हैं. Okay, but this is not there in the option, guys. This is not there in the option. That is right because this will come out minus 9. ये minus आएगा because this will go this side, so this will be minus 9. Okay, वो सही है आपका, उससे आप ट्राई कर सकते हो. But I feel the answer will be this only, 111.11 Newton per meter. Okay, chaliye guys, let us move to the next question. Let me solve first 25th question in front of you, then we will move to the 24th also. This is 25th question, guys, in front of you. Please try. There is a horizontal disc. So this disc is horizontal. This entire arrangement is horizontal, guys. So this disc is horizontal. Okay, we are actually getting some kind of top view. We are observing this arrangement from the top. Okay, so there is a horizontal disc which is having mass 2 kg, rotates about its center. This rotates about its center, connected to 2 springs as shown in the figure. If the spring constant of both the springs, this is having spring constant K, this is also having spring constant K, and both the springs having spring constant 500 Newton per meter, the angular frequency of the disc when rotated slightly from its equilibrium position. So he is asking you the angular frequency. So guys, which method you will apply it here? It's a case of rotation. So it is good to apply here the torque method. Or what you can say, it is very similar to the Newton's second law of motion. What is that? Newton's second law of motion tells us the algebraic sum of all the forces in the direction of displacement, that is equal to the product of mass into acceleration. Similarly, torque method tells us the algebraic sum of all the torques, okay, in a particular direction, that is equal to the I theta double dot. So in rotation, torque method, the algebraic sum of all the torques, that is equal to I theta double dot. Okay, now if you will check it here, if you are displacing this spring by a small angle theta, for example, you are displacing it by a small angle theta, so the deflection of the spring will be x. Okay, and can I write it here that x equal to r theta? Yes or no? Can I write x equal to r theta? Yes, x is the deflection of the spring and x equal to r theta. Okay, so if x equal to r theta, okay, then how much will be the spring force is going to act? Here the spring force will act in this direction. Here also the spring force will act in this direction. And how much that will be the spring force? that is kx kx. Both the sides, the same is the stiffness, same is the deflection. Okay, here the deflection will be this side, so spring force is going to act this side. Here, the when you are going to rotate this disc, the deflection will be this side, the spring force will be this side. Okay, and both the cases, the spring force is k into x. Now, how much is a torque, guys? If you write it here, the torque method, I theta double dot, that is equal to minus of what? This particular torque is what? How much is the force? Force is kx. What is torque? Torque is force into perpendicular distance. So that is kx into r. Again kx into r. So solving this, you will get minus 2kxr. Further, you can replace this x. 2k, x is nothing but what, guys? X is nothing but r theta into r. Okay, how much is moment of inertia for disk, guys? Disk के लिए moment of inertia कितना होता है बच्चों? How much is moment of inertia of disk? That is mr square by 2. So m is the mass, r square by 2 into theta double dot. So I am using it here, the torque method. The product of inertia into angular acceleration, I theta double dot, that is equal to algebraic sum of all the torques. Okay. Further simplification, if you will carry out theta double dot by theta, okay, that is equal to what, guys? ये क्या हो जाएगा? That is equal to minus 4k into r square divided by mr square divided by 2. अच्छा ये 2 ही है बच्चों. There is no 2 times. There is only single 1 2. Okay, so there will be 2 only, guys. There will be only 2. Let's check it out. ठीक है, there will be only 2. So this will cancel out. You will get it here minus 4k by m. Minus 4k by m. This minus you can take this side. So this is minus theta double dot by theta is nothing but omega n square is nothing but 4k by m. Now you need to put all the values. 4 into how much is k, guys? Stiffness is 500. How much is mass? How much is mass? Mass is how much is the mass? Mass is 2 kg. So let me put it here 2 kg. So you will get it here 1000. So omega n will be under root 1000. Omega n will be under root 1000. Okay. Under root 1000. So this will be what, guys? This will be under root 100 into 10. So this is 10 under root 10. Okay. So this will come out close to 31 point something. Because this will be 3 point something, guys. Under root 10. This will be 3 point something. And 10 into 3 point something, you will get 31 point something answer. So C क्या हो जाएगा बच्चों? C is the right answer. 31.4 radian per second. Yes, 31.4, close to this. If you are getting answer close to this, guys, 31.62 radian per second, this is also very right. So he asked you some approximate answer. The natural frequency, approximated natural frequency for this case will be. I hope this method is very much clear to you. If you want to try this torque method, you can try it for this case, guys. If you want to try this torque method, guys, it is good to try for this case. So there is another case. Okay, मैं इस तरह के क्वेश्चन ज्यादा सोल्व करने वाला नहीं हूं because those are not required for HPCL or BHEL. But yes, for practice, for getting some kind of idea related to torque method, you can solve this method also, this question also. So there is a rod, guys. This rod is actually pivoted with some kind of strings, यहाँ से, and now you are revolving this rod about its center. इस रोड को आप क्या कर रहे हो? इसके सेंटर के अराउंड क्या कर रहे हो? आप रिवॉल्व कर रहे हो, समथिंग लाइक दिस. नाउ ही इज आस्किंग द नेचुरल फ्रीक्वेंसी इन दिस केस. इस केस में आपसे क्या पूछ रहा है? नेचुरल फ्रीक्वेंसी पूछ रहा है. What will be the natural frequency in this case? Again, you can apply it here, the torque method. Let me tell you how to apply. Guys, here this rod is having mass mg. This rod is having mass mg. So this mass you can consider concentrated at the center. So how much will be the tension here in this particular string? The tension will be mg by 2. How much will be the tension here in this string? That is also mg by 2. Because the load is at the center, the tension will be same in both the cases, mg by 2, mg by 2. And now this is going to oscillate about its center. This is going to oscillate about its center, guys. In that case, the moment of inertia of the rod about its centroid, about its mass center, that is equal to ml square by 12. Okay. तो अगेन आपको यहाँ पे क्या लगाना पड़ेगा? टॉर्क मेथड लगाना पड़ेगा. द प्रोडक्ट ऑफ आई थीटा डबल डॉट दैट इज इक्वल टू समेशन ऑफ ऑल द टॉर्क्स. ओके, I theta double dot equal to summation of all torques. If you will do that here also, this force, but यहाँ पे distance क्या लेना पड़ेगा? The distance will be L by 2. This is L by 2. This is L by 2. But here the angle will be L by 2 sin theta. So mg by 2 sin theta into L by 2. That is a torque this side. And same also this side you will get torque mg by 2 mg by 2 into L by 2 into sin theta. Okay, where theta is the deflection. So in that case, if you will solve, you will get some answer. That I'm not solving. That is not required also. Now let us move to this question. This is the last question, guys, for the today's discussion. Okay, 3-4 question I will share only just for practice purpose, guys. These questions are not directly related to vibrations, but these questions are related to some kind of mechanics part and vibrations. Okay, so these are mix of mechanics and vibration question. These 3-4 questions are mix of vibrations and mechanics question. You can try this question also. You can try 28th question, 29th question. This is also a kind of different question you can find in the examination. 29th, and this is another question, guys, you can try. So ये 3-4 questions, 3 questions I'm not solving here. I'm just giving you just to try. Okay. This is also a very good question, guys. A rocket is on a horizontal launching platform. There is a pendulum hanging from it. When the rocket is fired, its acceleration A is such that the pendulum start oscillating with its other extreme position, being at the angle from the vertical, then the value of A in terms of gravitational acceleration. Okay. So if you want to try, actually, you can try these 2 questions. This one, 29th, 28th also you can try. This also you can try. Okay. Otherwise, for this question, I've already given you the idea. If you will solve this, you will get the answer this. अब इसको solve करके देखना using the torque method, you will get this answer. So I planned 25 question, guys, for the today's session. This is the last question we are going to solve. 24th question. Okay. There is a vibrating machine of mass 100 kg is mounted on a rubber pad, has a stiffness of 500 Newton per meter. Determine the force transmitted to the foundation if the unbalanced force is 500 Newton. Guys, what is force transmissibility? There's nothing but force transmitted to the foundation to the unbalanced force. Okay, and this is what? This is under root 1 plus 2 zeta omega by omega n square divided by under root 1 minus omega by omega n square whole square plus 2 zeta omega by omega n square. Okay, now he has given you this ratio, guys. This Ft he is asking you how much is the force transmitted, and this Fo is given to you 500 Newton. Force transmitted he is asking you how much is the force transmitted. Unbalanced force is given to you 500 Newton. Damping factor is given to you zeta 0.5. Okay, and this ratio omega by omega n is also given to you. Omega by omega n is also given to you how much? 1.5. Okay, please try this question. Please try this question. चलिए बच्चों, so these are the questions I planned for the today's session. I hope you revised some part of the vibration through these 25 questions. 3-4 questions I have not discussed because those are not directly related to vibration. Like a case of a kind of curve you are going to get when some person dropped some kind of ball from a building and you are moving in a vehicle. Okay, that kind of question that is related to vibrations, that is related to mechanics part. And one more questions that is there related to the mechanics part. Okay, so that those two questions are actually mix of mechanics and vibration questions. I'm just leaving to you. If you want to try those questions, you can try, but this one you need to try at least. ये आपको जरूर ट्राई करना चाहिए, the questions related to the torque method. Already I have given you the idea. Both the sides, the tension will be same. The perpendicular distance will be L by 2, but some angle you need to take, that is sine theta. So mg by 2 here, the restoring force will be mg by 2 into L by 2 sine theta. Further, for small angular displacement, sine theta you can write it as theta only. So mg by 2 into L by 2 into theta. This the restoring force is going to act this side and this side. Then if you write again this torque method, I theta double dot is algebraic sum of all the torques. But what is the moment of inertia, guys, for the rod about its central axis? Okay, that will be ml square by 12. Okay, not at the ends, at the center you need to take. So I value will be different. If you will put all those things, you will get the answer w under root 3g by l. Please try this at least. Otherwise, most of the questions which you showed from 1 to 20, those are typical question which you can expect in the examination, guys. They're not going to ask you much more numerical question because that much time they're not going to allow. Just for practice purpose, I have taken some questions. Don't feel yes sir, why actually you are solving those kind of difficult or complex numerical question related to magnification factor or transmissibility. Guys, when we are studying any particular topic, I try to pick question from each and every topic, like basic part, the basic terminology related to vibration, harmonic motions, springs in series, springs in parallel, simple questions related to vibrations, under root k by m. Some questions I solved related to the damped, undamped, critical damped question. Then we move to magnification kind of things, transmissibility, whirling of shafts. So I picked a question from each and every topic just to revise the entire this particular subject. But it is very difficult actually for in covering all those questions in the time limit of 1 or 2 hours. Okay, I hope these whatever questions we have solved in the today's session are very much clear to you. Further, if you faced any kind of difficulty or any query you are having, you can mention your query, you can shoot your query in the comment section. Thank you, have a nice day, keep preparing. And again, yes, these kind of sessions we will have continuously for other kind of subjects also. Monali, surely we will try. There must be some classes on the YouTube. Okay, regularly we are conducting some classes on the YouTube. Yesterday you had a class with Saklani sir. Day before yesterday you had class with Gaurav sir. And yes, some more classes you are going to get on YouTube also. But yes, some part of the classes will be there, 10-15%. Majorly classes will be there on the panel through YourPedia YouTube panel, YourPedia panel website for HPCL Micromodule and BHEL Micromodule. Chale guys, thank you. Keep preparing. Good luck. Have a nice day.